Hey everyone, welcome to the 3.5 notes. Today we're going to be learning about special right triangles. There are two special right triangles. One's called a 30, 60, 90, and the other one's a 45, 45, 90. And then after that, we're going to talk a little bit about Pythagorean triples. So here's what we're going to do. We're going to find the altitude of each equilateral triangle. So the red dotted line here is the altitude. So we have to figure out what angle measures were made in each triangle. So because we know that this is an equilateral triangle, each of the angles here was 60 degrees. Okay, because the equilateral triangle is also equiangular, so we know that this angle is 60, this angle down here is 60, and then what we have to remember is if this is an equilateral triangle, that dotted red segment is not only an altitude, it's all four of those special segments that we talked about. So it's also a median, meaning it cuts this side in half. It's also a perpendicular bisector, which is why it's 90 degrees here and splits the segment in half. And then it is also an angle bisector. So that entire top angle was 60 degrees. Because we split it in half, we now have 30-degree angles. All right, so let's look at the side lengths of this triangle. Each side here is 10, correct? So this side is 10, this side is 10. Because I split it in half, now I know that each of these little pieces has to be 5. So how am I going to find the height? That's what I need to find is the height of this. Let's use Pythagorean theorem because I have right triangles here where I have one of the legs and I have the hypotenuse, so I'm going to do Pythagorean theorem. So h squared plus 5 squared equals 10 squared. The hypotenuse is 10, so h squared, one of the legs, plus the other leg squared is going to equal the hypotenuse squared. Let's clean this up. 5 squared is 25, 10 squared is 100. Let's subtract 25 from 100, we get 75, and now I square root both sides to get h by itself, and I get, typically I would get plus or minus the square root of 75. But because this is a side of a triangle, we don't want negative side lengths, so I'm not going to include the negative square root of 75. As always, let's simplify this. What perfect square factor is inside of 75? It's 25 times 3. The square root of 25 is 5 root 3. So my height of the triangle, the altitude is 5 root 3. Okay, let's see if we could look at the next problem and see if we develop a sort of pattern about the side lengths. Here, again, we have an equilateral triangle. This dotted segment is not only an altitude, it's a perpendicular bisector. It's an angle bisector, so what I end up with here, because this whole side was 8, each of the little sides is going to be 4. Looking for the heights, we're going to do Pythagorean theorem. h squared plus 4 squared equals 8 squared. Let's clean this up. 4 squared is 16, 8 squared is 64. Let's subtract 16 from both sides. 8 squared is going to equal 48. And let's simplify the square root of 48. What perfect square factors go into 48? 16 goes in there 3 times. So h is going to equal the square root of 16 is 4 root 3. So the height here, 4 root 3. Let's see. Do you see a pattern? Here, when the side was 8, and then we split it into 4 and 4, the height was 4 root 3. In the first example, when we split the side of 10 to 5 and 5, the height was 5 root 3. That is going to bring us to the relationship and the pattern that always exists in any 30, 60, 90 triangle. So this is going to be true for any right triangle that's 30, 60, 90. So here, if the hypotenuse or the side length is 2L, half of that length was each of the little legs when we split it. Then this is the 60 degrees, this is 30 degrees. The height is always going to be L root 3. Whatever that leg is, when you split the side, The height is always going to be that number times the square root of 3, 100% of the time. Something that I want to mention is that in a triangle, the shortest side is always across from the smallest angle. So here, across from 30, which is the smallest angle, is the shortest side. L is going to be the short leg. Across from the 60-degree angle, because that's our medium length angle, is the medium side. L times the square root of 3 is going to be the leg times 1 point something, almost 2, but not quite. And then across from the 90-degree angle is the longest side, the hypotenuse. The hypotenuse in a right triangle is always 100% of the time the longest side. Let's take a look now at example number 4. It says, find the length of the hypotenuse in terms of the sides of the right triangles. What are the angle measures in the triangle? All right, well, the first thing I notice is, yes, we have a right triangle, but it's an isosceles right triangle because the legs are congruent. So therefore, we could find each of these angle measures, the acute angles, we could find them. In a triangle, the 3 angles have to add up to 180. The right angle here took up 90. So these two have to add up to 90 and be congruent. So what is the length, or what is the measure of each of these angles? It has to be 45 degrees. Okay, so when you have an isosceles right triangle, the acute angles 100% of the time are going to be 45 degrees. Again, if we have isosceles, we learned the isosceles triangle theorem. If the sides are congruent, the base angles are always going to be congruent. All right, so let's go ahead and we'll call the hypotenuse x. Let's do Pythagorean theorem. You're going to have 3 squared plus 3 squared, because our legs are congruent, equals the hypotenuse x squared. Cleaning this up, we get 9 plus 9 equals x squared. X squared is going to equal 18. Let's take the square root of both sides, ignoring the negative, because this is the length of a triangle. Lengths can't be negative. X is going to end up equaling square root of 9 times 2. Square root of 9 is 3 root 2. 3 square roots of 2. Hopefully we're looking for patterns here. And I do hope that you notice that the hypotenuse is the leg times the square root of 2. So because my legs are 3, the hypotenuse is 3 root 2. If my legs were 7, the hypotenuse would be 7 root 2. And so that leads us here to the rule for a 45, 45, 90 triangle. The hypotenuse is always going to equal the leg times the square root of 2. All right, so here are our 2 patterns for 30, 60, 90, and 45, 45, 90 triangles, our special right triangles. Everything is in terms of the short leg in a 30, 60, 90. If you know the short leg, whatever number this is, to get the long leg, you're going to take that length and multiply it by the square root of square root of 3 to get the long leg, and then double it to get the hypotenuse. In a 45, 45, 90 triangle, it's L for the legs, and then the hypotenuse is leg root 2. We don't call it a short leg or long leg because they're exactly the same length. So there is no such thing as one of them being short and one of them being long, like there is in a 30, 60, 90. One warning that I'm going to give you is please don't think that all right triangles are special right triangles. There's only 2 of them. The rest are just not special right triangles. They're right triangles, not special. Here, how can we tell this is a 30, 60, 90 triangle? Because we know that angle is 60, this angle must be 30. So it's a 30, 60, 90. If there are no angles written in there and you don't know that it's isosceles, you cannot assume that your teacher forgot to put an angle measure in there. Okay, there are other right triangles. They're not all special. Okay, so what I like to do with these problems is go ahead and label the sides. I know that across from the 30 degree is L. The other leg is L root 3. And then the hypotenuse is 2 times L. Now what you're going to be looking for is an equation where you have only one variable. So if I look over here, I don't know x, I don't know L. Can't solve there. I look over here, I don't know y and I don't know L, so I can't solve that side. Over here, there's only one variable. So I like to go ahead and write a little equation because I need to find L. Everything is in terms of L, which is the short leg. So if L is equal to For root 5, I could solve this by dividing both sides by 2, and L is going to equal 2 square roots of 5. Okay, so then, because x is equal to L, x here is going to equal 2 square roots of 5. Y is equal to L, which I just found, right? L is 2 root 5. But now I have to take that and multiply it by the square root of 3. Hopefully you remember from when we multiplied radicals, I'm going to have 2 times the square root of 15. Because when you multiply outside numbers with outside numbers. There's an invisible 1 in front of that square root of 3. And then 5 times 3 is 15. So those are my two answers here. X is going to equal 2 root 5. Y is equal to 2 root 15. These do take practice. You can't use your calculator and do Pythagorean theorem or anything like that. You have to be able to solve these using these special patterns, not a calculator. Okay, let's look at this next one. We have a right triangle, and we have a 45-degree angle, which means this is also 45. Okay, so as I said before, I like to label the sides. It's L, L, and the hypotenuse in a 45, 45, 90 is L root 2. So looking for one of these to be an equation where I could solve for L, notice right here, oh, I have a leg. So I could right away now say that y is equal to, let me put that in pen, y is going to equal 6 because y equals L, and then I'm going to plug L in here to get x. X is going to equal 6 square roots of 2. So when you're doing special right triangles, always keep telling yourself, I need L. I need to find L, 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 L. L is the most important thing because once you have L, then you can go along and fill in the pattern and find the other sides. Now you are going to have to memorize those patterns. It's not like this is going to be given to you. You're going to have to know 30, 60, 90 and 45, 45, 90 triangles, how to label the sides and find it. Number 3 over here, we have to figure out what type of special right triangle it is. Because I have L and L, I see that I have an isosceles right, so that means it's a 45, 45, 90. So 45, 45, 90 can be presented to you multiple ways. The angles could be marked congruent, the acute ones. The legs could be marked congruent. You could notice yourself that the legs are congruent, but regardless, they're going to give you a few different ways you could identify it's 45, 45, 90. A 30, 60, 90, that's not the case. Many times you have to be given either the 30-degree angle, the 60-degree angle, or both. All right, so here we have L, L, and now the hypotenuse is going to be L root 2. So clearly this is going to be the equation that I'm solving for because I'm going to be able to try to get L by itself. So let me rewrite this. And there's going to be a little bit of radical review here because to get L by itself, I have to divide both sides by the square root of 2. Square root of 2 is a number, so I divide it away. So L is going to equal 10 divided by the square root of 2. Hopefully you remember from a few units ago or chapters ago, we rationalized the denominator. So rationalizing the denominator means you don't want to have a radical in the denominator. So whatever the square root is in the denominator, we're going to multiply top and bottom by that number. Because square root of 2 over square root of 2, remember this is equal to 1. So I am not changing the fraction's value. I'm changing how it looks, sure, but I'm not changing its value. So now multiplying numerator times numerator, I'm going to get 10 square roots of 2. On the bottom, square root of 2 times square root of 2, that's the square root of 4. Simplifying this, I would have 10 square roots of 2. I can't simplify square root of 2, but the square root of 4 does equal 2. Now because these are factors, I could simplify 10 root 2 divided by 2. I can only simplify those two numbers, not the radical, but I would end up with 5 root 2. Okay, so that is what L equals, and I am done with the problem. All right, so let's take a look at number 4 here. As you can see, there is a 60-degree angle, which means by default, this one has to be the 30. Okay, so let's list our sides. The side across from the 30-degree angle, which in our case is X, it's going to equal L. The leg that's across from the 60-degree angle, the longer leg, is L root 3, and then the hypotenuse is 2 times L. So that is the first step here. You label all your sides. Now you're looking to see where do you have a little equation where you only have one variable. Here I have x and L. Can't solve for L here. Over here I have 15 equals L root 3. There's my answer. There's the one I'm going to solve first. So 15 equals L root 3. I have to get L by itself. So if it's being multiplied by the square root of 3, I divide both sides by the square root of 3. All right, this is going to give me L equals 15 over the square root of 3. We cannot have radicals in the denominator, so we have to rationalize. Because it's a square root of 3 on the bottom, we're going to multiply by square root of 3 over the square root of 3. Because square root of 3 over square root of 3 is just 1. So now, on top, I multiply. 15 times the square root of 3 is just 15 times the square root of 3. Divided by square root of 3 times square root of 3 is square root of 9. That's the reason we multiply by square root of 3, because we're always going to make that a perfect square. So now I could simplify the square root of 9 to be just 3. These two numbers, because we don't have terms, we have factors, we can reduce and get 5 root 3. Okay, so now if I'm solving for x and y, I'm going to take what I found for L, I'm going to plug it in here, and then I'm going to plug it in there to get y. So if x is equal to L, x is equal to 5 root 3. Y is equal to 2 times 5 root 3. When I multiply here, I'm going to do 2 times 5 is 10, square root of 3. Okay, so x, because it's L, is 5 root 3. Y is going to equal 10 root 3. At first, if this is it's tricky. It's a different, you have never done anything like this before. So it takes practice, and then once you kind of perfect it and practice it, students typically could do it really quickly. They could solve special right triangles rather quickly. All right, and then for number 5, we're going to find the exact area of this equilateral triangle. So area of a triangle, in case you don't remember from earlier math classes, is 1/2 the base times the height. Or you could write this as base times height divided by 2, because a lot of times that 1/2, kids don't like the way that looks, so they just rather multiply the base and the height and then divide by 2. All right, so if I'm looking at this triangle, my base is here, my height is the altitude inside, so I have to find the base and I have to find the height. This is a lowercase b. All right. Because it's equilateral, I know that all 3 sides are congruent, so therefore I know that the whole base here is equal to 9. So to find the height of this triangle, it's going to be very similar to the first few problems we did today. The first thing we did was we took this side length of 9 and we divided by 2. Well, those numbers were actually divisible by 2. This is not, so we're going to write it as 9 over 2. This is my 60-degree angle. This is my 30-degree angle. So let's use our special right triangle knowledge to label these sides. This is 2L. The hypotenuse is always 2L. Across from the 30-degree angle, that's L. And then the long leg, which in our case is H, is L root 3. So I have L. I'm going to take this number. I could plug it in here. I don't need to. 2 times 9/2 is 9. I'm looking for the height, so I'm going to plug it in right there. So the height of this triangle is 9 over 2, root 3. All right, so now we have enough information to find the area. Area is equal to 1/2 the base, which we said right here is 9, times the height, which is 9 over 2 root 3. Okay, this is kind of ugly to multiply, but what I could do is I'm going to write that 9 as 9 over 1, and in my numerators I have 1 times 9 times 9, that's 81. In my denominators, 2 times 1 times 2 is 4, and then I could just bring along that root 3, or I could put the root 3 on top with the 81. Because it's area, we don't know the units, we're going to call it units squared. Okay, I am sure that we're going to practice those much more in class tomorrow to kind of get the hang of it and the patterns and figure out how to do that rather quickly. Okay, and then last problem here on special right triangles, we are going to find the exact, meaning no decimals, all just radicals, perimeter of the trapezoid. Perimeter, don't forget, is the distance all the way around. So far, we only have these two lengths. We have 14 and we have 12. We need to find this side over here from T to P, and then we need to find from P to A. How are we going to do that? By creating right triangles, dropping the altitude from both vertices up top, from R and from T. Hopefully what you notice here is that we have two special right triangles. The one on the left is a 45, 45, 90, and the one on the right is a 30, 60, 90. You need to have at least one side length to be able to find the other side lengths. So if we focused first on this triangle, the 45, 45, 90, I'm stuck. I don't have any information. I don't have any lengths, none of the legs. I don't have the hypotenuse. I can't do anything with that. However, if we focus on this triangle first, it's a 30, 60, 90, and we have one of the side lengths. So let's go ahead and label our sides. So across from the 30-degree angle, which would be up here, up here, this is L. The other leg, the long leg, is L root 3, and the hypotenuse is 2L. We are looking for an equation that we could solve for L. It's right here. So if 12 equals 2L, L is going to equal, if I divide both sides by 2, L is going to equal 6. So now I know that this length is 6 and the height is 6 root 3. So now that I've gotten that, I take this, the height is not going to change of this trapezoid. If it's 6 root 3 over here on the right, it's 6 root 3 over here on the left. So in a 45, 45, 90, we have L, L, L root 2. So now, if this is equal to L, 6 root 3, I know that this length is 6 root 3, and this length is 6 root 3 times the square root of 2, okay? Because the hypotenuse has L root 2, I have to also multiply in that root 2. So the hypotenuse here is going to equal, final answer, 6 root 6. So now we have everything we need to find the perimeter. Let's go ahead and add up all the sides. So the first side I'm going to add here, PT, is 6 root 6, plus top piece over here, 14, plus this side, 12, plus this little piece, 6, plus what would this piece equal? Well, if up here is 14, if I bring that down, this segment is also going to be 14, plus, last one, 6 root 3. All right, so let's see what we could combine here. If I have 6 root 6, I would need another root 6 to be able to combine with that. I don't have it, so I just bring it down. Plus, now let's look at our constants. We have 14 plus 12 plus 6 plus 14. That is going to be a grand total of 46. Let me just pause and double check my math, make sure that that's right. 20, 34, yes, 46. And then plus, this is a root 3, so we have no one to combine that with, 6 root 3. So the perimeter here is 6 root 6 plus 46 plus 6 root 3 units. These three terms, in any order that I write them, would have been fine. So if I had 46 plus 6 root 3 plus 6 root 6, that's absolutely okay. All right. Okay, so the last thing we're going to talk about here is Pythagorean triples. And what those are is they're just time/calculation savers, just like special right triangles. You should be able to recognize the pattern and then not have to do Pythagorean theorem. You could just use Pythagorean triples to find missing side lengths. Okay, so here are a few of the most popular Pythagorean triples that you'll see, like a 3, 4, 5. a 5, 12, 13, an 8, 15, 17, and a 7, 24, 25. So what that means is if you were to add the two shortest sides, how we did in an earlier section, right, where we were doing the Pythagorean theorem inequalities, because we get 20, you would do 3 squared plus 4 squared. See what its relationship, that sum, is to the longest side, 5 squared. They're equal, that means it's a right triangle. Same is true for 5, 12, 13. The sum of the squares of the two shorter sides is equal to the longest side squared. So what we're seeing here is it's a squared plus b squared equals c squared. So all of these triples are the tops of the family of triples. So what that means is like a 3, 4, 5. What we did here is we multiplied 3, 4, and 5 by 2, giving us a 6, 8, 10. What we did here is we multiplied them by 3. What we did over here is we actually divided them by 2. So as long as you apply the same operation to the three original triples, you will have Pythagorean triple. So for example, 300, 400, 500. That is a 3, 4, 5 that was multiplied by 100. And then the same is true for these. So here we multiplied by 2, multiplied by 3, divided every side by 3. That's how you get 5 thirds, 4, and 13 thirds. And then the last one, what did we do? We multiplied by 2 to get 16, 30, 34. We multiplied by 3 to get 24, 45, 51. And then we divided by 2 to get 4, 15 halves, 17 halves. So knowing some of these triples can help speed up your mental math calculation abilities. So let's try a few of these. We're going to put our calculators away. All right, over here, 12 and 9, those are my legs. So, and you'll start recognizing these a little bit, I think, easier as well. But this is my 3, 4, 5 triangle. And what did we multiply? What did we multiply 3 by to get 9? That's what we're seeing. Like, what were these triples multiplied by? Hopefully you're saying to yourself, they were multiplied by 3, so x is going to equal 15. So now if you look up here, we have another right triangle. We have 8 and 15. Notice that is a Pythagorean triple. So right away, I would know then it's an 8, 15, 17. So here, x would equal 15, y would equal 17. All right, looking over here, I have my right triangle. The only one that there's a bunch of right triangles in this picture, but the only one that I have two sides on is this one. And so it's going to be an 8, 15, 17. Over here, I recognize that this is a 3, 4, 5 Pythagorean triple. What was each side multiplied by? It was multiplied by 2, so x is going to be 5 times 2, aka 10. 10 and 26. Looking back up at our triples, 5, 10, and 26, that is a 5, 12, 13. So this is a 5, 12, 13. What were these two multiplied by? What was 5 multiplied to get 10? What was 13 multiplied by to get 26? Hopefully you're saying to yourself, it was 2, so I know this side has to be 24. And now, if you look, our last triple has a 24 and a 25, the two sides we have, so this side has to be 7. Okay? This last problem, I would like you to try to find this on your own. Find the h value. Notice we have a triangle here that's a triple. And then you'll be able to find x because this side's going to be 12. You have to find the distance from here to here. Okay? Try that one on your own and see what you get. Pause the video. I will tell you what we get for x. And I should mention before I even display what x is equal to, or yeah, what it actually, the value is, this entire side length from here to here, from 6 on to the right to p, that is going to be x. So when you find x, it's going to equal 12 right here plus whatever length you get for this leg of this right triangle. Okay, so pause the video, find h, find x, check against my answer. Okay, hopefully using Pythagorean triples, you found that the height of that triangle had to be 8. So then that means this is also 8. And then using Pythagorean triples, you found that question mark value down there and then added it to 12. So x ends up being 27. Okay, that's it for the 3.5. You will be practicing this in class. Don't have a calculator because you're supposed to be able to do this without using a calculator. Thanks for watching, everyone. Have a great day. Bye.